Hello friends, I am Ankita Meshram. I am taking Structural Engineering, Assistant Professor in Civil Engineering Department at Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur. I welcome you all in today's video lecture session which is based on subject Surveying 1. The topic I am going to deal with in today's session is contouring. So begin with the lecture. So what is meant by contour? So basically a contour is an imaginary line on the ground surface joining the points of equal elevation is known as contour. In other words, contour is a line in which the ground surface is intersected by a level surface obtained by joining the points of equal elevation. This line on the map represent a contour, or you can call as a contour line. So basically contour is an imaginary line joining the points of equal elevations on the ground surface. Next is the contour map. A map showing contour lines is known as contour map. A contour map gives an idea of the altitudes of the surface features as well as their relative positions in plan, serves the purpose of both plan as well as section. So as you all can see that a ground features represent in this way in a map. Okay. Next terminology is contouring. The process of tracing contour lines on the surface of the earth is basically called as contouring. So this is an image displaying over here showing the various contour lines represent on a map which is the actual features of the ground surface. In this way you have to represent the contours. Okay. Next, the purpose of contouring. So, contour surveys carried out at the starting of any engineering project such as roads, railways, canals, dam as well as building, etc. So, initially prior to the construction, first of all you have to carry out the survey. So, basically a contour survey is carried out for determining the features of the ground. So, number one is for preparing contour maps in order to select the most economical or suitable site. Number two, to locate the alignment of a canal so that it should follow a ridge line. Number three is to mark the alignment of roads as well as railways so that the quantity of earthwork both in cutting and filling should be minimum. So, these are the some purpose. Because of that we perform the contouring. Next, for getting the information about the ground, whether it is flat, undulating or mountainous. In short, the topographical features of the ground. Next is to find the capacity of reservoir and volume of earthwork, especially in a mountainous region. Next, to trace out the given grade of a particular route. Next is to locate the physical features of the ground such as pond, depression, hill, steep or small slopes. Okay. Next, the important terminology is the contour interval and the next is horizontal interval. So, the constant vertical distance between two consecutive contours is called as contour interval. That means the vertical difference between two elevation basically called as contour interval. Next one is horizontal equivalent. It is the horizontal distance between any two adjacent contours is called as horizontal equivalent. Okay. So, the contour interval is constant between the consecutive contours while the horizontal equivalent is variable and depends upon the particularly slope of the ground. Okay. Next, what are the various factors on which the contour intervals depend? So, number one is the nature of ground. It is a very important factor. Okay. So, in flat and uniformly sloping country, the contour interval is taken as small, the interval is small. But in broken and mountainous region or undulating surfaces, the contour interval should be large, otherwise the contour will come close to each other. So, this particular phenomena you have to remember while performing the contour survey. Next, the purpose and extent of the survey. So, the contour interval is small if the area to be surveyed is small and the maps are required to be used for the design work or for determining the quantities of earthwork, etc. So, for determining the quantities of earthwork, the contour interval is taken as small, while wider intervals shall have to be kept for large areas and comparatively less important works. So when the work is very important, when we carried out the survey for the important purpose, then you have to make the interval of contour small, as well as when the less important work is going on, you should take the interval in a wider way. Okay. Next, the scale of the map. The contour interval should be in the inverse ratio to the scale of the map, that is, the smaller the scale, the greater will be the contour interval. This is the basic concept while selecting the scale for the map. Okay. The next one is time and expense of field and office work. The smaller the interval, the greater is the amount of field work and plotting work. So, जितना आप interval कम select करते हो, that means उतना ही greater accuracy से आपको survey perform करना पड़ेगा. So, when you select the smaller interval, you should do the survey work with greater accuracy. The plotting work should be more, as well as field work should be more. Okay. Next, the common values of the contour interval which is generally adopted for the various purposes. Number 1, for large scale maps of flat country, for building sites, for detailed design work and for calculation of the quantities of earthwork, then generally the contour interval is adopted as 0.2 to 0.5 meter. Next, for reservoirs and town planning scheme, the interval is taken as 0.5 to 2 meter on ground. Okay. For the location survey, the interval is as 2 to 3 meter. For small scale maps of broken country and for general topographic work, the interval should be 3 meter, 5 meter, or you can take 10 meter or 25 meter also. So, this is the some adopted intervals you have to adopt while performing the contour survey. Next terminology is the different characteristics of contour. So, all points in a contour line have the same elevation. Next, the flat ground is generally indicated where the contours are widely separated, and steep slope where they run close together. So, when the contours are widely separated, it is considered as a flat ground, and when the contours close together, then it is considered as a steep slope ground. Okay. Next one is a uniform slope is indicated when the contour lines are uniformly spaced, and a plane surface when they are generally straight, parallel and equally spaced. Okay. So, based on the nature of the contours, we conclude the topography of the ground. We conclude the nature of the ground based on the nature of the contour lines. Okay. Next is, see here, a series of closed contour lines on a map represent a hill if the higher values are inside. So, as you all can see that the ground surface, the elevation is 60 meter, and at the top of the hill the elevation is 80 meter. So, while represent the hill on the map, you should draw the contour like this. Okay. The higher value is inside the circle, which indicates it is a hill. Okay. And the smaller value outside in the circle. Okay. Smaller value is in the outside and greater value is in the inside of the circle. This particular diagrammatic representation represent it is a hill. So, this is, in this way you have to plot the contour on a map or on a plan. Next, a series of closed contour lines on the map indicate a depression if the higher values are outside. So, it is vice versa. If the higher values is at outside and the smaller value is inside in the closed contour, then we generally conclude it is a depression or it is a valley. Okay. So, as you all can see that an image displaying over here, the RL of the below ground portion is 60 meter and top there is a 80 meter RL. So, basically it represents a depression over here because the higher value is at the outside of the closed contour. Okay. Next, a contour line cross ridge or valley line at a right angles. So, if the higher values are inside the bend or loop in the contour, it indicates a ridge line. Okay. So, this is basically taken along the alignment of the hill or on the alignment of the valley. Okay. So, next is when the contour lines cross ridge or valley line at a right angles, if the higher values are outside the bend, it represent a valley. So, basically these are the some characteristics of contour. Next one is The contours cannot end anywhere but close on themselves either within or outside the limits of the map. Next, a contour lines cannot merge or cross one another on a map except in the case of overhanging cliff. So, when there is a overhanging cliff occur in the topography of the area, then the contour may cross each other or they can merge also. Okay? So, this is the diagrammatic representation of overhanging cliff. Next, a contour lines never run into one another except in case of the vertical cliff also. So, in this case several contours coincide and the horizontal equivalent becomes 0. So, in the vertical plane the contour get coincide with each other. As you all can see that the image displaying over here is an example of vertical cliff. Next, a depressions between summit is called as saddle. So, basically it is a depression which is there on the field. So, it is represented by 4 sets of contour as shown in figure. It represents a deep in a ridge or the junction of 2 ridges, and in the case of a mountain range it takes the form of a pass. So, the line passing through the saddle and summits give the watershed line. So, this is the example of saddle. Then moving forward to the methods of contouring, they are mainly classified into 2 categories. Number 1 is direct method and number 2 is indirect method. So, one by one I am going to deal with both the methods. So, first of all, the direct method. In this method, the contours to be located are directly traced out in the field by locating and marking a number of points on each contour. These points are then surveyed and plotted on a plan and the contours drawn through them. So, basically the direct method is carried out over the field. Each and every point's elevation should be determined on the field itself. So, it is a very tedious method, but it is very accurate. Okay? Though it takes a time to perform the surveying, but it is a very accurate method. Okay? So, this is the example of direct method. You have to set up the benchmark first. You have to assume the benchmark, that is the elevation is already known, or you can assume the elevation. Now, set up the leveling instrument, and with the help of this reference point benchmark you can carry out the survey and locate the points of equal elevation and draw an imaginary line connected by connecting this point, which is called as the contour line. So, here in this case there are 5 points having the same elevation, that is 46 meter. Next one is another, there is a 5 points having the elevation 48 meter, then 5 points having the elevation of 50 meter. The line joining this point of same elevation is called as contour line. So, in this way you have to perform the direct method on field itself. So, this method is most accurate but very slow and tedious because it takes a lot of time to perform the survey. So, this is unsuitable for the large area, but it is very suitable for the smaller area, and where great accuracy is required you have to adopt this direct method. Next one is again direct method by the radial lines. This method is suitable for small areas where a single point in a center can command the whole area. Radial lines are laid out from the common center by theodolite, or you can use compass also, and their positions are fixed up by horizontal angles and bearings. So, in this way you have to perform the direct method by the radial lines concept. Next method is indirect method. So, in this method the points located and surveyed are not necessarily on the contour lines, but the spot levels are taken along the series of lines laid out over the area. The spot levels of the several representative points representing hills, depression, ridge and valley lines, and the changes in the slope all over the area to be contoured are also observed. So, the position are then plotted on a plan and the contours drawn by with the help of interpolation method. This method of contouring is also known as contouring by spot levels. Okay. So, square method is one of the method of indirect method. Okay. So, over the field you have to divide the whole area into the number of small squares, and the corner of the square is considered as a point where you have to measure the elevations. So, basically an elevation is determined of the corner points. As you all can see that a whole square, a whole ground is divided into number of small square, and the corner of each square is the elevation of the corner of each square is determined with the help of leveling operations, and by adopting the interpolation method you are able to find out the points of same elevations, and the line joining the points of same elevation is a contour line. So, in this way you have to obtain the contour lines. Okay. So interpolation of contour is a very important topic because in indirect method you have to adopt this interpolation method for calculating the points of equal elevation. So, the process of spacing the contours proportionally between the plotted grounds point is termed as interpolation of contours. This becomes necessary in the case of indirect contouring, as only the spot levels are taken in this method, because in indirect contouring you are not able or you are not supposed to carry out the survey or determine the elevation of each and every points. Only you have to take the elevations of the spot points. Okay. So, while interpolation of contours, the ground between any two points is assumed to be uniformly sloping. So, there are three main methods of interpolation. Number one is by estimation. The position of the contour points between ground points are estimated roughly, and the contours are then drawn through this point. This is a rough method and it is suitable for the small scale areas or for the small scale maps. Number two is arithmetical calculation. This is very tedious but accurate method, and it is used for small areas where accurate results are necessary. So, the contours are interpolated as under follow. Then the next method is the graphical method of interpolation. It is a very simpler method as compared to arithmetical method, and also the results obtained are accurate. With the help of graph you can able to plot the contours over the map or plan. Next. So, these are the some uses of contour map displaying over here. So, the uses are as follows. Number one, the contour map furnishes information regarding the features of the ground, whether it is flat, undulating or mountainous region, or there is a valley. Okay. From a contour map, sections may be easily drawn in any directions. Intervisibility between two ground points plotted on a map can be ascertained. It enables an engineer to approximately select the most economical or suitable site for any engineering project such as road, railways, a canal or pipeline, etc. Because with the help of contouring, we are able to find out the actual topography of the ground, actual features of the ground. So, it is very helpful to find out the alignment of road, railway as well as canal. So, for determining the alignment of the road, railway, canal, the contour survey is very important. Okay. Next one is a route of a given grade can be traced on the map. Next, the catchment area as well as the capacity of the reservoir may be determined with the help of contour map. Then contour map may be used to determine the quantities of earthwork also, which is very useful while we construct the roads, railways. Okay. So, while performing the earthwork calculations, contour survey is very important from that point of view. So, thank you so much. Hope you will able to understand, or you should clear all the concept related to the contouring survey. Thank you so much for attending the lecture very patiently.